So are you hearing my voice? If the screen is visible, is the screen is visible? Is my voice is clear? Okay. Okay, so that is all about IO device. Okay, so once the IO communication. So it may be the inter-process communication, or it may be the inter-computer communication. Okay, two systems, communication between two systems. Communication between two systems may be intranet or internet. Communication between the two processes may be inter-process communication. So all these services, user interface, program execution, error handling, file systems, IO management, communication, everything are provided in view of the user to provide some flexibility for the user. To provide some flexibility, to get the services from the operating system. These are the services that are provided by the operating system for the user. Is it clear? So next, another very important thing is system-based services. Only user-based services are not sufficient to utilize your computer and to get the good services. Okay, if you want to get the good services from the operating system, there should be some system-based services also. Okay, so because in user-based services, the operating system is not taking care about the system. Is not taking care about the system. It is just concentrating mainly in view of the user. Mainly in view of the user. So it is not sufficient. So you need to concentrate on the system also. So if you want to concentrate on the system, there are three major services it has to provide. The operating system has to provide. One is resource management. What do you mean by resource management? Here, what are the different resources that are available in any system? What are the different resources available? Please respond. What are the different resources that are available in the system? Please respond in chat box. What are the resources that are available in the system? What resources your operating system has to manage? What resources your operating system has to manage? Please respond in chat box. Okay. What resources your operating system has to manage? What resources your operating system has to manage? Main memory, okay, hard disk, file management, memory management, IO management, everything, communication. So if you want to implement all these things, there are different resources that are available. Main memory is there, and hard disk is there, and RAM is there. If you want to provide the communication, you have to network card is there. So like this, there are number of resources that are there, and number of processes are created by different users. And what resource that was there in your system, how much it was utilized. Okay, so whether they are ready or not, whether they are busy or not. If they are busy, you have to inform to your user. If they are not busy, then you have to make available your, if the user is asking for that particular resource. So that will call it as a resource allocation. So resource allocation. That means if the resource is available, you have to allocate it. If the resource is not available, you have to make you have to inform it. Okay, so sometimes the resource may be shareable resources. Sometimes the resource may be non-shareable resources. Is it clear? If the resource may be a shareable resource, then more than one user can use at a time, directly use that particular resource at a time. If the resource is not shareable, then one by one, you have to um, uh, you have to make it a queue, and one by one it has to utilize. Is it clear? So this is how the resource management can be done by the uh, operating system. Then accounting. Then accounting means the number of, what are the number of resources that are available, which user is utilized what resources, when it was allocated, how much it was already utilized, okay, how much is already utilized, and what it needs, what more it needs, that user needs, what more resources that user needs, and those resources are available or not. If they are available, you make them available, and if not, you have to make it some message that resource is not available. It will come and you have to wait. Okay, so how much time the user is utilized a particular resource, how much time it needs still, and when he is going to release that particular resource, everything will be maintained in the accounting. This accounting is utilized by the resource allocation. This accounting information is utilized by the resource allocation. Based on this accounting information only, the resource allocation will be taken place. And based on the resource allocation, the accounting information will be updated. So mutually, your operating system is going to do these two activities. Okay, if the resource allocation is done, it should be updated in the accounting. If the accounting is there, then according to the accounting, the resource allocation will be done. For example, a printer is given to the process 1. Then in accounting, process 1 is allocated with printer 1. Then process 2 is waiting for printer 1. Process 2 is waiting for the printer 1. Then resource allocation will refer this accounting. Yes, process 1, the printer 1 is already busy with the process, printer 1 is already busy with the process 1. So process 2 has to wait. So resource allocation mechanism will send a response to the user that you have to wait. Then again, the resource allocation mechanism will watch this accounting. Then accounting will be updated once the printer 1 is released by the process 1. Once the printer 1 is released by the process 1. Once it was released, then accounting will update it. Then resource allocation service will look into this accounting information. Okay, printer 1 is released by the process 1. So process 2 can avail printer 1. Then resource allocation, that means printer 1 is allocated to process 2. So this is how the system based services will be done by the operating system. Is it clear? Then protection and security. There are two different aspects. There are two different components. One is software components and the hardware components that are there in your system. So to protect both software and hardware components, we have different protection mechanisms and security mechanisms are maintained by the operating system. Okay, so this is very much burden on the operating system, but it needs. So if you want to protect the resources, if you want to protect the process, a software from the malfunction users or unauthorized users. Okay, the users may be any type. If he is an authenticated user, then they can able to utilize the resources. If he is an unauthorized user and is not authenticated, then the operating system has to restrict the unauthorized or unauthenticated users. If you want to implement, if you want to provide some restriction between the authorized users and unauthorized users, the system has to utilize some mechanisms, protection mechanisms and security mechanisms. So these protection, what are the different protection and security mechanisms, we'll discuss in the last chapter. Discuss in the last chapter. So these are the system-based services, resource allocation. What resources that are available, how to allocate it, and how to deallocate it. Once it was completed, you have to deallocate it. And once allocation and deallocation will be done, parallelly accounting should be maintained by the operating system. Okay, so accounting has to be maintained by the operating system. So these are the major services that are provided by the operating system. Operating system services are mainly classified into user-based services and the system-based services. So you can observe the architecture. So you can observe the architecture here. So this is all about user interface, GUI, batch. We'll see what do you mean by batch, command line interface. So you may use the user interface, GUI, the user interface may be command line interface. Then program execution, IO operations, file system, communication, resource allocation, accounting. These are all the services. But so these are the services in view of the user, and these are the services in view of the operating system. So error handling is also the user point of view service. It is a very strong mechanism in view of the user. If the error detection and error handling is not there in your system, operating system is not providing the error detection and error handling. Not only detection, error handling is also there. Most of the services can be handled by operating system. So there are built-in error handling mechanisms also there in the operating system. But if they can't handle the errors, then only those errors will be reported to the user. Otherwise, the operating system itself will handle those errors. Okay, that is the mechanism. That's a major advantage. Okay, so next, these are the different services. So next, I'll just look into simple function. List out. I'll try to list out different functionalities. So just it is repeated. Okay. So functions of operating system. There are again there may be components or functions or services, whatever it may be. So they are listed like this. Process management. This is the next chapter, second chapter, process management. We'll discuss in detail what is process and how to create the process and how to delete the process, how to terminate the process, how to suspend the process, how the process is going to behave in your system, what are the different states of process, how the process are communicating with each other. Everything will comes under process management. Is clear? That is called process management. This is one module of functionality that was implemented by the operating system. Next, memory management. Memory management means here you remember the memory management means main memory or RAM management. Okay, memory management means main memory or RAM management. Okay, so memory management means how the RAM is managed. What are the different memory management techniques? We have different techniques. Swapping technique is there, paging technique is there. We will discuss different advantages and limitations of swapping, paging, and combination. Segmentation is there. Paging and segmentation combination is there. Okay, so different memory allocation mechanisms and how to manage the memory, free memory, nala manage state. Everything we will discuss in the memory management. Okay, next, file management. So in this file management, I already explained you how to create, what is file and what is directory, and how the files are created, and how the directory structure is created, in which the files are managed, and what how to create a file, how to read a file, how to write a file. We'll discuss in the file management. how to access the file, how to copy the data from one file to another file, and how to delete the file, everything, how to manage the files, everything will be comes under the file management. So again, device management. Here the devices means input devices, output devices, and as well as IO devices and input output devices. Okay, how the, I already explained you how what are the different IO devices and how to manage the IO devices. So all these things will come under the device management or IO device management. Next, job accounting. Here the job accounting means what are the different processes that are created in your system. Job, you can also here call it as process. Job or process. Okay, so how the process is, how many processes that are created, what resources are allocated to the what process, how much those processes are already utilized, how much it's still they needed, and what are other resources that are required when the process is going to complete its functionality, when the process are going to release the resources that are allocated to them. Everything will be comes under the process accounting or job accounting. Is clear? This is another functionality that was done by the process operating system. Next is secondary storage management, and it is also called disk management. Okay, so in memory management we'll discuss different memory management techniques or RAM techniques, RAM management techniques. Here the disk management techniques. So some disk management techniques are there. If you want to read the data, it is a hard disk is a special architecture when compared to the main memory. It contains disks. Disks are divided into sectors, and each sector will contains some data, and different cylinders will be there, and each the sectors will be read by the read-write head. Okay, and how to manage that, how to move that, and how optimally you can get the data from the hard disk, and how to optimally you can store the data into the hard disk. All these things will come under this particular secondary storage management. Is it clear? So we'll discuss in detail. Next, process management. Here the process management is again repeated. So sorry. So here the process management is repeated. Next, networking. So the networking means, already told you, either it may be intranet or internet. That means your system is connected to the systems which are there in your office or the systems which are there in the old. So okay, so your system may may access any other system which is there in the world, or your system may access by some other system which is there in your office. So that is called internet and intranet. Okay, so how these internet and intranet, your operating system, your system has to access different users. So your operating system has to do that particular functionality. So if it is in internet, so how to do that? If it is intranet, how to do that? How to provide the main challenge in networking is security. Without security, firewalls will be there, and some mechanisms are there, security mechanisms, protection mechanisms are also. The protection mechanisms are generally for within the system, and security mechanisms are in between the systems, computer systems. Okay, so all these things will come under the networking. When there are a number of issues are there, so you have to send the data to another process. Different traffic problems will be there, and data should be make it in packets. So maybe you are already covered in DC data communication. Okay, how the data will be converted into packets, and how they are passed through the networks. What may be the problems in the networks, and what is the role of operating system in sending the data to the other operating system, and how the other systems, operating system, has to access that particular data that was sent by the other system. So everything will come under the networking. Okay. Next, coordination between the other software and users. Okay, so user to user communication. For example, maybe you may already experienced client server architecture. So you discuss. So user wants to access the other user. Okay, or one software wants to access the data from the other software. Intercommunication, coordination between the software and the user. Software and the users, different users. Okay, so that will come under this operating system. Without operating system, these functionalities are not possible. Under the supervision of the operating system, all these things will be done. All these things will be done. These are the different modules that are implemented in your operating system. These are the different modules. And again, process management is having some submodules. Memory management is having submodules. File management is having some submodules. Okay, and these are the different modules that are there in your operating system. Okay, so with this first part is over, and the second part I'll go with. So in the previous presentation, I concentrated on basic aspects of the basic aspects of operating system. Now, so in this, the outcome is, by the end of this presentation, students can able to list different operating systems and its functionalities. Okay, so till now, a general operating system we discussed. So now I'm going to explain a specific classifications of operating systems and what are the advantages and what are the limitations. So from age-old operating system to the present currently utilizing operating systems. Okay, then outline different interrupts and how they are handled by the operating system. Okay, outline. Already told you in IO management, interrupt. The user will raise an interrupt, and he will sit and he will do their own work. And once the interrupt is completed, he will get the response. Okay. So now in this particular presentation, I'm going to cover interrupts. What is interrupt? What are the different types of interrupts, and how the interrupts are handled by the operating system. Next, list different operating system structures. Okay, monolithic structure, layered structure, microkernel structure, and outline the merits and demerits of those structures. Okay, so this is the part 2 introduction. It is also in the chapter 1 only. So I'll go into types of operating systems. So here, the how you can classify an operating system. Can you please, anybody, please respond? How can you classify any operating system? Can you give some parameters? Can you give some parameters? What are the different parameters to classify any operating system? Please respond in chat box. How can you classify any operating system? How can you classify any operating system? How can you classify any operating system? Can you please respond fast? Is my voice is clear? Please respond. Is my voice is clear? Is my question is clear? Okay. Then, how can you classify any operating system? But, we already discussed different functionalities. Whatever the user is going to do. Maybe you're not discussed in detail, but what functionalities it will do, we already discussed. Okay, so can you, based on these functionalities, Can you classify the operating systems? Can you classify the operating systems? Yes, exactly. Multiprocessor. Okay, multiprocessor. Then multi-user. Okay, multi-user. Anybody? Just one is correct. Okay. 297. Multitasking. Okay. Okay. That's the only thing. So there is no other classifications. So you already using different operating systems. You already using different operating systems. Already last semester we used Unix. What is the type? What is the type of operating system? Yes, exactly. 211 real-time operating system. Exactly. Okay. Then okay. So leave it. Okay. I'll try to cover one by one different types of operating systems. So mainly here we are going to discuss different operating systems based on its functionality. Based on its functionality. Okay. I'll try to explain you one by one. I'll try to explain you one by one. Then you can identify different functionalities. First one is batch operating system. So please try to understand this first operating system. Then it is very easy to understand the remaining operating systems. Okay. So here what I am showing here is a RAM. Here what I am showing is a RAM. Okay. Then half part I am using operating system, and the remaining part I am using for user space. I am using for the user space. Okay. Please try to understand. Okay. So this is the kernel. This is the kernel mode, and this is the user mode. Okay. So this is the kernel mode. This is the RAM. This is RAM. Okay. So this is the RAM, and this is the kernel mode in which your operating system is running. This is the user. This is the space which was utilized by the user. This is the space which was utilized by the user. The first and uh, very basic operating system is batch operating system. First and basic operating system is batch operating system. What do you mean by batch here? Batch means different process. For example, these are the different processes. Okay. So say, let us consider three processes: P1 to P5. P1 to P5. Initially, before converting it into process, they are the programs. Okay, P1 is having one functionality, P2 is having, P3, P4, P5 is having their own functionalities. Is it clear? P1, P2, P3, P4, P5 is having their own functionalities. And here, after P1, P2 has to start. It will take whatever the output that was generated by the P1, P2 will take. Then P2 will do some functionality and it will respond some output, and that output will be given to P3. Then P3 will use that P2's output and P3 will run and it will generate another output. And P3's output will like that all the P5 process are dependent with each other. Then I will make this as one batch. I will make this as one batch. Okay. P1, after P1, P2 will be executed. After P2, P3, P4, P5. Okay. Then I will give the input here only. Please remember input. Okay. Input is given for the P1 process. Okay, and P1 will use that input and it will generate output, and that output will be given to the P2, and P2 will generate the output, and that output will be given to the P3, P4, P5. Then ultimately the output will be given by the P5. Is clear? Then we'll call this is the batch. Okay, a set of similar jobs arranged sequentially is called a batch. Is clear? Please respond. Is clear? What do you mean by batch is clear? Batch means a set of process or jobs that are arranged in a particular sequence. Okay, then in batch, remember in batch input will be done only one time, and the sequence in which the process are arranged, in that sequence only your process, your operating system is going to execute one after the other only. Please try to understand the concept. P1 execute first by taking the first input and it will generate the output. Then P2, P3, P4, P5. Ultimately, P5 will give you the output. Until unless the user has to wait. Okay? User has to wait. Until unless completion of all the P5 process, user has to wait. Is it clear? Okay, I'll again explain you. Batch, in a batch operating system, user has to design a batch of process. User has to design a batch of process. User has to design a batch of process. What is the time? Okay, user has to okay, so user has to start a batch of process. Then once the batch is submitted to the system, okay, so number of process are submitted to the system. sorry, so number of process will wait. So this batch, this is the batch. So this batch is submitted to the operating system. Then your operating system will first take this particular process and it will execute here. It will execute here. Then once it was completed, then the output will be taken by the operating system. Output will be taken by the operating system. Then next, the second process will be loaded into the RAM. Then this output will be given to the second process. Then third process will be loaded into the RAM. And at a time, only one process is under execution. Only one process is under execution. Is it clear? So OS is going to execute the batch. Then another very important thing is, once, for example, if your batch is having 10 process, the user has to submit the 10 process batch to the operating system, and he has to wait by giving the first input to the first process. Okay, so he is not allowed to do anything. The user is not allowed to do anything. Okay, until unless the total batch execution is completed and the last process will give the output. The last process will give you the output. Is it clear? So 10 process means the first process will take the user input and it will do the functionality. It will generate the output and it will use the input to the second process. Second process will be started by loading that second process into the RAM. Okay, and at any time, at any point of instant, the RAM is loaded with only one process. The RAM is loaded with only one process. That is the major problem with this. That is a major problem with this. Okay. So maybe you already understand what is batch operating system. I hope you understand the batch operating system. Okay. Now in the next class, I will ask what are the merits and demerits of batch operating system. You have to tell. Okay. So what the batch operating system is doing, it will the user is creating a batch and he is submitting the total batch and he is giving the input to the first process, and the operating system will execute the process which are there in the batch one after the other in that sequence only in which the process are arranged in that batch. In that sequence only it will execute. Is clear? Then it will generate the output. The last process will generate the output. The user can able to view the last one. The user is not allowed to interact with the second process, third process, fourth process, fifth process. No, he is not allowed to interact with any other process. He has to submit the batch and he has to keep quiet, and until unless the 10 processes are executed in that particular sequence, then only the user can able to get the output. Is it clear? This is all about batch process. So you have to tell me, so what are the advantages and limitations? I will ask you what about the CPU utilization, what is the multi-programming, what is multi-threading, multi-processing, everything. So you have to tell me what are the advantages and limitations of the batch operating system in the next class. Okay. Time is over, so I'll stop here. Okay, thank you very much.